Welcome to the lectures on Module 9, Address Resolution. I think I'll probably do 3 lectures on this, one on just what address resolution is, kind of introduction, then do, probably the MAC and the IP address, ARP, and then IPv6 neighbor discovery. So let's go. Question is, why should you take this module? Well, the biggest thing is IPv4 addresses have run out, at least as far as assignable addresses. So things have had to been created to maximize the use of the IP address. But a big thing is when you try to go from, especially the data link layer, you're just going from device to device. And what do you need? I need the MAC address for the different devices. Well, address resolution is how do I go about getting those MAC addresses when I don't know them. So hopefully in this whole module, we'll pick up a little bit about the roles of the MAC address and the IP address, look at the address resolution protocol, and look at the neighbor discovery. So like I said, probably 3 videos. So the MAC and the IP address, to get any message between 2 devices, you need to have basically two addresses that need to be done, a physical address and a logical address, similar as your address at home. Your physical address is the MAC address, and the logical address is the IP address. The MAC address is assigned to a network interface card, and your IP address is stuff that your system defines. Now, as you can tell, as I'm sending information between different devices, I need both the IP address from PC1 to PC2, and I need the MAC address between the differences. And as you're putting that frame together at the layer 2 level, this is where you're assigning, you're putting on the destination MAC and source MAC address. But there's some cases you don't know. It's just like when you're trying to send a message, you may know the IP address, but you definitely don't know what is the next device's physical address. So what we need to do is make sure we find a way to assign a destination MAC address to find out what it is. The same thing applies. Destination IP address is about the same. Now, it even gets more complicated when I'm talking about a remote network, because when I've got a destination IP address for a remote network, the only MAC address that you may know is the default gateway. So when you're sending your message out, all you're doing is saying, what's my address between PC1 and the default gateway? Everything else beyond that, you have no clue what that MAC address is for PC2. So all you can focus on is because that's all the data link layer worries about, is what is the next physical device that has a say in transmitting this data. So when the message continues to move on, so when it goes, so you had it, from PC1 to the gateway, then the gateway says I got to go to the next router that gets me to the internet. So what is it stripped off the frame, inserted both the destination and source MAC address of the next device. So as we're routing a packet all the way through from source to destination, every device we're going through, we're verifying if this is the right device. If not, strip it off. Find out where it's going. What is the routing table? What is IPv4 or IPv6? What's the destination? And do I know how to get there? And if I know how to get there, I then create a source MAC address and a destination MAC address and forward the package back on. So that's kind of what you're going to be doing. And the same thing goes all the way through when you get to the final source. Now, I didn't assign the packet tracer 1.3, but I think it's a good thing to just to have you go through and look at it and see how that works for you, how it works. And then I would double check your understanding as you go through. So I'm going to go on to my next video for ARP, and we'll see you then.